The garbage collector is a special feature of C# that automatically clears objects from memory when they are no longer needed. For example, once a method has finished execution, the garbage collector removes any variables it used from memory. Thanks to the garbage collector, it's very rare for C# applications to suffer from memory leak issues, where the program uses up more and more memory until it overloads the system. The garbage collector will work automatically without you needing to do anything, but you can send commands to it by using the GC class. The GC class can also provide some useful information about memory usage. In this lesson, you'll use the GC class to give commands to the garbage collector. To begin, open the StableBase project from your Sample Files folder. And open the code behind file of scheduleadmin.aspx. The getSchedule method on this page creates a list collection of task row objects in order to display a schedule on the page. The garbage collector will automatically remove the collection from memory eventually, but you can use the GC class to tell the garbage collector to remove it as soon as the method is finished. First, you're going to use the GC class to examine how much memory is being used before and after the method. Add the following code to the page load event handler just before the call to the getSchedule method. Response.write memory usage before getSchedule method plus gc dot get total memory false plus an HTML break tag. Now add the following code just after the getSchedule method is called. Response.write memory usage after getSchedule method plus gc dot get total memory false. Now view scheduleadmin.aspx in your web browser and examine the lines at the top of the screen. This indicates that 13,631,268 bytes of memory were being used before the getSchedule method was called, and 14,824,640 were being used afterwards. These numbers will always be different depending upon your computer's current state, so you won't get exactly the same values. You should always find, however, that the second number is higher than the first one. By subtracting the two numbers, you can see that calling the getSchedule method added 1,193,372 bytes of memory usage to your application. That's over 1 megabyte. Close your web browser now, and you're going to add some code to tell the garbage collector to clean up memory as soon as the getSchedule method has finished. Add a new line just after the getSchedule method is called, and add the code gc.collect. This tells the garbage collector to clean up memory immediately after the getSchedule method has finished. View the page in your web browser once more, and once again examine the lines at the top of the screen. The garbage collector cleaned up 17,437,256 bytes of memory when you called its collect method. However, not all of this memory was allocated by the getSchedule method. The garbage collector cleaned up some other objects that were added by the virtual web server. Refresh the page by using your browser's refresh button. This time, the difference is much smaller, only 543,552 bytes. You might even find that your application is still using slightly more memory after calling the method than before it, but the difference will be much smaller than it was before. You might think that telling the garbage collector to clean up memory has made a huge improvement to the project's memory efficiency. But it's important to remember that the garbage collector would have eventually done this automatically. It's really never necessary to tell the garbage collector to clean up memory, but it is useful to understand how it works and how to use it to monitor memory usage. It's important to be aware that using the garbage collector improperly can make your project less memory efficient. The garbage collector files your objects into one of three categories, also known as generations. Generation 0 contains objects that will be disposed of quickly, such as variables within methods. Generation 1 contains objects that are expected to remain in memory for longer. A public property of a class might be a Generation 1 object. Generation 2 contains objects that are expected to remain in memory for a long time, such as static classes. When the garbage collector cleans up memory, it promotes any objects that are still in use to the next generation. Misusing the GC class could lead to objects being promoted to inappropriate generations and remaining in memory for longer than they should. If in doubt, just avoid using the GC class. Close your web browser now and close Visual Studio. You've now completed Lesson 2.8. Send commands to the garbage collector.